decides who they'd be directly publishing with? How does the, like, is science like borderless, where there are like no, like, you know, there's no hostility between labs, or is there?
I think my perspective as an undergrad doing research in labs and now starting off as a graduate student, the atmosphere here is one of very much openness and collaboration, and I've yet to see an experience or an interaction with a PI that I worked with or was only tangentially related to. Most people say, how can we combine our two ideas into something even higher impact or much cooler than this? I think everybody's pretty open to collaboration, and my experience has largely been at U of M, so I think it's pretty open.
U of M is, if not unique, it's at the top of the order when you're talking about this phenomenon. I chaired the search for a new provost many years ago, about 12, 13 years ago here. And when we had what are called the airport interviews, this is airport interviews are when you bring in your candidates, your semi-finalists, and they're airport interviews because they're literally held at an airport hotel. You bring them in one door, you take the other one out the other door, and you're with them for an hour and a half, 2 hours. It's very intense. You do it on a weekend. We had 14 people, which was a lot. Usually you're doing about 8 or 9. And I think it was 9 or 10 of them when they were asked what's the most important characteristic of the University of Michigan, or what are the best characteristics. 9 or 10 of them mentioned the fact that this is the most interdisciplinary university in the country and the easiest one to cross the boundaries of the different departments and schools and presumably labs as well. So I very much agree with Steve about the ease of working with people here. That's not the norm around the country, and NIH has been struggling to figure out how to make sure that data that are produced with their funding are available to everybody. There is a legitimate role to keeping the data private within your own lab or your own shop for a period of time, so you can have the chance to exploit what you've produced. It's sort of analogous to a very short patent on a drug or something. Right. But after that, you want to be able to make it open because it's publicly funded so that other people can use it. And that has been a bone of contention in many issues around the country. We like to think science is open and that it's as collaborative and cooperative as it is at the University of Michigan. That's not true everywhere. Harvard, for example, is known to be incredibly siloed. So if you go from one school in Harvard to another and try and get cooperation there, it is very difficult to do it. And as a former dean, I can tell you one of the reasons is if there's a grant and that grant gets split up between 2 units, I'm not getting all the overhead. And most
explain what overhead is.
Yeah, overhead is it's actually what you were mentioning. When you get a grant from NIH, and this is negotiated university by university, but the rate, I don't know what it is today, but it's about 53%. So you get 53% of whatever your direct costs are, your research costs. You get an extra 53% to cover what's called overhead. So it's things like keeping the lights turned on, paying the rent, secretaries. You used to be able to put secretaries in your grants. You don't do that anymore. Other staff, like administrative staff, it's all literally the indirect costs of doing your research. So we figured out in our school that it cost us on the margin about 20% at least to get a grant. So I'm getting a new grant very shortly from Robert Wood Johnson Foundation. I'm expecting to get it. They only pay 13%. Foundations don't pay much indirect. That means I have to figure out where to get enough money out of the direct costs to cover the balance so I can pay 20%, because otherwise it would literally cost our school money for me to accept this grant. Wow. So the 53% or whatever the number is what the university figures is the cost. It's negotiated with Health and Human Services. They do it every couple of years. It changes. It varies from probably the high 30s at some universities to as high as 70% at other universities. But as a dean, you want to get as much indirects as you can, because this is a big source of our revenue. Our 2 big sources of revenue are tuition and indirects, the overhead. Those are our 2 biggest sources. Our school happens to have the largest amount of research per faculty member of any school in the university by far. We're about $600,000 per faculty member. Med school and engineering are about 300 or 350 or something, and then the others all are much below that. So we live and die on how much we can bring in on these indirects. But because it's University of Michigan, if somebody, my faculty member comes to me and says, you know, I've got something I want to do over in biochem, I want to work with them, and we're going to split the costs. We're going to share the direct cost, and they're going to get their share of the indirects. The ethos in this place is such that I could never say no to that. I wouldn't even think about it. At Harvard, they probably wouldn't permit it because they don't want to lose the indirects. So very different models depending on where you are.
I was talking like on that idea of like science and research being kind of a business, or a business. What do you think? Like especially as someone from the public health things, or anyone. The idea of like people not trusting like our health information doing science. Things like people trusting that what Oprah says about vaccines more than what CDC says about things. How do you think? Because you bridge that, like bridge the connection between these people who research and talk about health and just that everyday person.
This is a problem across the board. If you're interested, there are actually 2 recent books about how science gets abused by industry sometimes, by other scientists sometimes, and by government. And one of them was written by McGarity and somebody. They're 2 Texas attorneys, and it was published probably within the last 3 to 4 years. But you could Google it, or you could find it. It wouldn't be hard. I think the public as a whole is probably pretty responsive to science and probably pretty believing. But the fact is, scientists make mistakes. It's an iterative procedure. You learn something, then you have to test it. Sometimes it's wrong, goes back and forth. Conventional wisdom about science changes periodically. And look at, you don't have to do health. Look at global warming. As I understand it, and that's not my area, the science is pretty strong, suggesting that human beings have contributed in a very dramatic way to global warming and to the carbon in the air and all that. But there are a lot of people who don't believe it. I don't know if it's a majority, but it's a sizable minority of the American public do not believe it. And it's because politicians, in some cases for their own purposes, don't want to believe it. If you're from Texas, and you're trying to get freer flow of energy, and specifically oil, you don't like this business about carbon dioxide and greenhouse gases, and you'll try and make a mockery of it if you can. So it's tough. I mean, it is a tough thing to do. Plus, there are scientists who cheat. Nobody likes to admit that, and we hope it doesn't happen very often, but it does happen. It gives everybody a bad name. I think the system that's set up to avoid that is about as good as any system you can imagine, between IRBs, these institutional review boards that look at grant proposals to make sure that it's not going to harm anybody, and the peer review system, which has flaws in it, but it's probably the best system we've got. Science that's published in the better journals is usually pretty good. How you sell it to the public is another question, of course. I don't know if that's answering your question.
Another question for Steve. So I guess just how does the whole MD PhD program work? First off, in terms of so it's an 8-year program generally. How do they separate up how's your time separated up in terms of between medical school and research generally? It probably varies between programs, but I guess for your experience. And then secondly, what would be your ideal job that you hope to have if you have super idea?
So yeah, the timeline can be confusing. The vast majority of programs across the nation take the 4 years of medical school. Your first 2 years of medical school, you're in a classroom getting lectures, you're dissecting a cadaver and anatomy, and you're learning about the human body and disease. And for the most part, your last 2 years of medical school, you're walking around the hospital in a short white coat, you're doing your different clinical rotations and